Hello everyone, welcome to Eduing. In this class we'll discuss about the difference between Princeton and Harvard architecture. Princeton architecture is also called as von Neumann architecture. In case of Princeton architecture, there is always a common memory for storing the control program as well as variables and other data structures. But the Harvard architecture executes instructions in fewer instruction cycles than von Neumann. That is because it has separate memory for program storage, stack, and variable RAM. In short, when the data and code lies in different memory blocks, then this architecture is Harvard. I repeat again, in Harvard architecture, the data and code lies in different memory blocks. If the data and code lies in same memory block, then it is von Neumann or Princeton architecture. That's the major difference. As you can see the block diagram, it is clearly visible that the data and code are available in the same memory block in case of Princeton or von Neumann architecture. In case of Harvard architecture, there is separate memory for data, stack, and also the code. If there is a separate memory for program, data, and stack, that will be Harvard architecture. So what is the advantage when you have separate memory blocks? So at the same time, when you have two different blocks, you have different blocks, when you have different blocks, then you can achieve instruction parallelism. Parallelism actually stands for parallelism is a process where the next instruction can already be fetched during the execution of current instruction. So at the same time, when you are executing a current instruction, you can fetch the next instruction. That is parallelism. So this is the main advantage of Harvard architecture, but in Princeton architecture, the main advantage is its flexibility, because now that you have counter-stack contents that can be accessed by the program, there is greater flexibility in developing software using Princeton architecture. In case of Princeton architecture, the memory interface unit is responsible for all functions like accessing memory space, for reading instructions, and passing the data to and fro within the processors and its internal registers. MIU, Memory Interface Unit, will be responsible for all this. The instruction decoder decodes the instructions, or in some simple terms, it lets the system know the meaning of the instruction and what operation has to take place. I request you to kindly go through both the block diagrams. Please pause the video and go through both the block diagrams for a better understanding. In the next video, we will discuss the block diagram of 8051 microcontroller. Thank you for watching all these videos. Have a great day.